lectures ago, we talked about the quotient property for radicals, where we said if you had a single radical, it could be written as the root of A over the root of B. Sometimes, like in the cases shown here, it's actually easier to leave it as a single radical, because if I look at 90, I can see that 5 is a factor of 90. So we can go ahead and prime factor 90. And we see we can simplify the fraction. We can also see that there are two factors of 3, and our index is 2, so we can take that 3 out. Now this leaves a 1 in the denominator, but of course the square root of 1 is simply 1, so we can ignore that. In the numerator, we're left with 3 outside of the radical sign and 2 inside. Let's try question 2 together. We'll write this as a single radical, and I'm going to prime factor everything right away. 75 y to the power of 5 all over 3y. Now again, I see that I can factor out this common factor of 3, and this 1y is going to leave me with 4y to the power of 4 in the numerator. I know that I can take out these two factors of 5. And we remember that when we're finding the root of a variable, we divide the exponent by the index. This is a square root, so the index is 2. Again, our denominator is 1. The square root of 1 is 1. I don't need to write this over 1. This simplifies to 5y squared. Pause your video and try question 3. You prime factored 54. We see we can divide out that common factor of 2, and dividing out this 1x leaves us with x to the power of 7 in the numerator. Now remember what we said when we were simplifying variables. I can't find the square root of x to the power of 7 without having a fraction. So I'm actually going to rewrite that as x to the power of 6 times x, because now I know I can find the square root of x to the power of 6. I have 1 in the denominator, and again, I don't need to write that 1. The square root of 1 is 1. It doesn't change my answer at all. I have two factors of 3 I can take out. I can also find the square root of that factor. So outside of the radical, we have 3. 6 divided by 2 is 3. Inside the radical, we have 3 times x. Did you get that? It's a pretty complicated process. Try question 4. We've prime factored everything. We can divide out a factor of 2. We can divide out a factor of 3. And we can take out 3 m's, leaving us m to the power of 12. In the numerator then, I see I have 2 factors of 2 that I can take out, and I can factor m to the power of 12. 12 divided by 2 gives me 6. Inside the radical sign, what's left? Just 3? I think so. If these are difficult, again, go back in this lesson, watch these questions again, try them again yourselves.